It takes a motorboat 4 hours to travel 56 miles with the current. And it takes 7 hours to make the return trip against the current. See, you're faster, same miles, but you only travel 4 hours. But here, it's 7 hours, but it's the same distance because you are going against the current. So you go slower. Yours, the speed of the ball will be slowed down by the current. So what are we asked for? We are asked to find for the speed of the boat in a still water. There's no current. It means in still water, there's no current. So it's entirely the speed of the boat. So what shall we do here? Let's represent the speed of the boat in still water. But we also do not know the speed of the current. So we need to represent both because we need them in our solution. So let's say let x be the speed of the boat in still water. How about the speed of the current? Let it be y. Let y be the speed of the current. The current is like the flow, right? It's usually by it- it's actually seen by maybe some waves. You know the direction of the current when you see waves going somewhere. So that's where the current is going. It's in that direction. And usually seen by the small waves that you see in the ocean or bodies of water. Okay, and that's the current. And now we have to find the equation. What's our equation here? Our equation is in order to find the equation, we need to create a table, just like what we did in our problems about downstream and upstream, where we create a DRT table. Remember that? DRT. Do we know the distance? All right, let's put the distance here. First one would be with the current. Right, so with the current. How about the second one? It's going to be against the current. All right, so with the current, and then against the current. So here's our table now. What's the distance with the current? It's the same, 57 miles. So both of these are 57. Our rate, what's the rate with the current? It would be the speed of the boat in still water plus the speed of the current. So that would be x plus y. How about against the current? It would be x minus y. Okay? It's against the current. That's why it's the speed of the boat minus the speed of the current. That's your rate. The rate or the speed of the boat going with the current, x plus y. And then in the return trip, the speed now would be x minus y. So this is the speed with the current, x plus y, and against x minus y. How about the time? What's the time traveling with the current? It is 4 hours. How about against? It is 7. Oh, this is not 57, it's 56. I'm sorry about that. I don't know where I got that, but it should be 56. All right, 56, and then x plus y, and the time is 4. For against the current, it's 56 distance, rate x minus y times 7. Let us solve this equation. Since distance is equal to rate times time, we can use that to form our equation based on this table. All right, our first equation will be 56 equals x plus y times 4. Okay. How about the second equation? It's going to be 56 equals x minus y times 7. So this is equation number 1, equation number 2. Our equation 1, 56 equals x plus y times 4 can be simplified, right? We can simplify it by dividing both sides by 4. And what's 56 divided by 4? It's gonna be 14. All right, so that's now equation number 3. This is now equation number 3. Let us also simplify our equation number 2. Our equation 2 is 56 equals x minus y times 7. We can simplify this by dividing both sides by 7. And now we get our equation number 4. 56 divided by 7 is 8. And that's equal to x minus y. And this is now our equation number 4. Using equation number 3 and number 4, we can solve for your x and y. So let's solve this system. Let's solve the system. 14 equals x plus y. And 8 equals x minus y. Let's see if we have opposites. We have x, they are not opposites. Y, negative y, they are opposites. So we can do addition here now. 14 plus 8. That's 22. Equals x plus x, 2x, and then you cancel y minus y, it's 0. We divide both members of the equation by 2, so x is equal to 11. And what can this do to our problems? To our problem? It says find the speed of the boat in still water. Now let's go back. We represented the speed of the boat in still water as x. So did we find x yet? Yes, we already found it. And that's 11 miles per hour. How did we know it's miles per hour? Since we are talking about the speed, the unit of the distance is miles, and the unit of the time is hour. So it would be miles per hour. Your rate will be miles per hour. Therefore, the speed of the boat or the rate of the boat is 11 miles per hour in still water. And we are done.